Alright, in this lesson we shall be discussing limit, and we are limiting this function x squared sine 1 over x, and we are tending x to 0. So the first thing we do here is test our value x at 0 and see what it gives us. So we have limit as x goes to 0 of x squared, sine 1 all over x is equal to 0 squared sine 1 all over 0. So we know 0 squared is 0. Multiply by this will give us undefined. So we have sine all over, then you have undefined here. So this point is undefined. So what do we do at this point? To make our life easier, we use what we call the Squeeze Theorem. So using the Squeeze Theorem, and it says that if you have a function like this, then and you can put sine in between two functions, then and the function on the right exists, also the function on the left exists, and both functions are equal to each other, then the function at the center also exists and is equal to the function on the left and the right. Now, what does this mean? It means that one of the properties of sine is that sine that we know, sine y lies between 1 and -1 for any value of y. We know this for sure, and this is one of the properties. It's a property of sine is that sine, for any value of y, sine y lies between -1 and 1. And if this is true, then we can say sine 1 all over x also lies between 1 and -1. So why are we bringing out this? Because we are trying to work our way to this question here. Now, we have this, but here we have this. Focus on the center. We have this here, and here we have this. What are we supposed to introduce here? Yes, you're right, x squared. So multiply through by x squared and see what we get. So here we give us negative x squared less than or equal to x squared sine 1 all over x less than or equal to x squared. So if we assume this function on the left to be h of x is equal to negative x squared, and we assume this one to be f of x equals x squared. Now, and we assume this one to be, let's say, m of x to be the entire function, the middle function rather, sine 1 all over x. Just watch me. You see? Now, what we know is this. X squared should be here rather. Now, what we know is this. What Squeeze Theorem says is that if the limit of the left hand side is equal to the limit of the the right hand side here, then the limit of the middle term here, it also exists and is equal to whatever answer you get here. Yes, that's what the squeeze says. You see that we have been able to squeeze this function in between two boundaries. That's why we call it the Squeeze Theorem. We have been able to squeeze this function in between two boundaries. If that is true, these are the boundary, the lower bound and the upper bound. And if that is true, the theorem for the squeeze says that if you are able to sandwich this man in between two functions here, then find the limit of the left hand side and the right hand side independently. If they exist and they are equal to each other, then the limit of the center, the middle term, which will correspond to the function itself, will also exist, and the answer is equal to the value you get here automatically. That's what the squeeze says. So let us find that out. So the limit as x goes to 0 of h of x equals to negative 0 squared, which is equal to 0. Okay, that exists as 0. Now the second one, now the limit as x approaches 0 of f of x, which is x squared, equal to 0 squared, which is equal to 0. Now this limit exists, this one also exists, and the limit as x goes to 0 of h of x is equal to the limit as x goes to 0 of f of x. So by squeeze theorem, the limit as x goes to 0 of x squared sine 1 all over x is also equal to 0. Thank you, and see you in the next lesson.